All right, let's dive right into this explainer. Today, we're looking at what is essentially a high-stakes chess match between messy human surprises and the rigid, calculated plans of next-generation artificial intelligence. We are witnessing a fundamental shift in how machines are learning to deal with the ultimate wildcard, us. So I want you to ask yourself a question. Can a rigid, rule-based algorithm truly anticipate our messy, emotional, totally unpredictable human behavior? Like, if you decide to do something completely out of left field tomorrow, could a computer have actually planned for it today? Well, that brings us to the core conflict here. See, traditional AI is absolutely phenomenal at crunching massive amounts of historical data. It loves rules, it loves patterns, but it often gets completely blindsided when we humans throw a real-world curveball. The second we deviate from the expected script, poof, the AI's perfect plan just falls apart. Section 1. The illusion of rationality. Let's take a look at exactly how humans break these rules. A really perfect example of this is something called the centipede game. Now, in classical game theory, mathematical models basically assume players are these perfectly rational calculators, right? Just trying to maximize their own individual payoff. So in the centipede game, standard theory predicts early defection, meaning players will selfishly end cooperation almost immediately, just to get the best deal for themselves. But empirical studies show something completely different. Real humans actually sustain cooperation way longer than the math expects. We just don't play by the cold, hard rules of pure logic. So why exactly does the math fail? Well, we have bounded rationality, meaning, we don't have infinite processing power in our brains. We care deeply about our reputation, we build trust, we have emotional biases, and we have pro-social tendencies where we genuinely just want to be fair. And these uniquely human traits, they are exactly the surprises that completely shatter traditional predictive models. The AI plans for a calculator, but it gets a human.
Moving on to Section 2, AI meets game theory. This is a massive bidirectional shift that kind of changes everything.
This shift is really the convergence of machine learning and game theory. On one hand, we've got traditional AI, which is essentially just passive data processing. It looks at yesterday's patterns to guess tomorrow's outcome. But on the other hand, we have game-theoretic AI, and wow, this is a real game changer. It acts much more like a master chess player. It doesn't just read old data. It actively formulates strategic plans, anticipating human reactions, and then adjusting its moves based on what it thinks we are going to do.
And this convergence has birthed what's called predictive game theory. Researchers are now combining machine learning with experimental economics and cognitive science to predict how people will actually play, not how a mathematical formula says they should play. For instance, researchers analyzed massive data sets of real people playing games and discovered these hidden regularities, like a specific risk aversion parameter. By programming this very human tendency to avoid risk right into the AI, they drastically improved the system's ability to predict our real-world moves. Essentially, the AI is learning to plan for our surprises.
Section 3. Predicting the stock market using machine learning and game theory. Let's take these concepts out of the lab and into one of the most volatile, emotion-driven environments on the planet.
Now, this visualization of expected payment against the probability of winning perfectly illustrates how we can apply hard math to messy human behavior. It literally maps out stable conditions, like the Nash equilibrium, right in the middle of absolute market chaos. It's helping analysts understand where the market might actually settle when everyone is just frantically trying to outsmart everyone else.
So the crucial takeaway here is how this creates a hybrid market advantage. The machine learning tools, things like neural networks and support vector machines, they're doing the heavy lifting, processing massive amounts of historical data to spot deep trends. But the game theory layer is what models the actual investor psychology. It anticipates that irrational herd behavior and those emotional biases that drive sudden market crashes or surges. So the ML spots the trend, and the game theory plans for the human panic.
All right, Section 4, Mastering Cyber Deception and Strategic Defense. Let's accelerate the pacing a bit here, because we're entering an even higher stakes environment where AI has to actively outsmart stealthy human adversaries in real time.
In strategic cyber warfare, defense absolutely cannot be purely reactive. You have to plan for the surprise. Modern security architectures use what are called foundation models to execute dynamic defense plans. First, the AI actually anticipates the attacker's strategy. Next, it deploys a deceptive digital honeypot, basically a fake vulnerability. And finally, it traps the adversary, tricking them into revealing their methods. It's a highly proactive, strategic game of deception.
And this flowchart maps out perfectly how this defense is structured. Notice how it flows from the top down. You've got a grand long-term security plan up at the strategic level. That trickles down to the operational level, and then finally down to granular, tactical AI actions at the bottom. What this means is, an AI can deploy a highly specific tactical trap, like that honeypot, based on a massive overarching strategy, predicting the human attacker's surprises before they even make a move.
Which brings us to Section 5, the co-evolution game between algorithms and users. This is really the absolute climax of this technological leap. Like, what happens when the AI's plans get so good they actually start changing human behavior in response?
This quote from researchers Eden Saig and Nir Rosenfeld represents a pretty profound insight. They highlight that AI no longer just passively observes us. Think about it. When a prediction algorithm gives us highly accurate recommendations, we engage more, we adopt those trends, and we fundamentally change our behavior. The AI is actively shaping our reality. They call this framework evolutionary prediction games.
And here is that co-evolutionary loop in action. First, the AI accurately predicts what we want or what we're going to do. Second, because of that spot-on prediction, we as users adopt the trend and actually change our actions. Third, because our behavior changed, the AI's previous highly accurate plan is now completely obsolete. Boom, a new surprise. And fourth, the AI has to adapt and replan for this new behavior. As the AI plans for our surprises, we adapt to the AI, forcing it to adapt yet again in this continuous, symbiotic loop of mutual evolution.
Which leaves us with this final thought. We've moved from algorithms that just crunch numbers to systems that anticipate our irrationality, set strategic traps, and actively evolve right alongside us. So, in this infinite game of algorithmic planning and human surprises, are you the player or are you being played? Thanks so much for joining me on this explainer, and I'll catch you next time.